Hey, you guys, I wanted to help you finish today's assignment, the LEGO reactions, because this is such an important concept for this year, understanding what happens to atoms and molecules during reactions. So I wanted to go through it together. And we're going to do that by doing one of the examples together. Okay. And we're going to choose combustion, which is this one that's in the yellow. And I'm going to zoom in on that. Combustion, by the way, this is the reaction that happens when you're burning something. That's combustion. Okay. In this example, we're burning natural gas or methane, but you don't need to remember that. Okay. But this is the reaction that's happening like inside of your water heater at home or inside of your furnace. We have this CH4 molecule, which is natural gas. Okay. That's like the gas company. That's what they're providing to you through the pipes that come into your house. And then this is oxygen molecules. And when we burn those, when we combine those, they burn and then they create carbon dioxide and H2O or water. And those two gases just leave your house through, up through your chimney or through like the pipe coming out of your roof. Okay. So what we're going to do, I'm going to walk through how to draw this. Okay. For those of you that are doing drawing at home. And then when we're done with that, I'm going to come down and I'm going to go through the conclusion. So even if you don't need this part, I would skip ahead, or I'd watch it and make sure you're doing it right. But even if you're not going to do that, I'd skip ahead and still go watch the conclusion because I'm going to go through it with you. Okay, I'm going to be using this really cool tool today called Sketchpad. It's a really useful drawing tool. I like to draw on paper more, but if you like to draw on the computer, oh, sorry, that's just another project I was working on. Let me just start over. There we go. Okay, Sketchpad is really useful for drawing if you prefer drawing on the computer, or if you're like me trying to show what you're doing. Okay, the first thing you need to do is we're going to fill in this box that says reactants, and we're going to need to take a picture to fill that in. Okay, so the reactants, you'll notice, are over on the left side. They're before the arrow. If we come up here to our reaction, we'll see, oh, everything over here is on the left side before the arrow. Those are our reactants. So that's the first thing we're going to draw is these molecules over here. We're going to draw down into this box. So I'm going to go over to Sketchpad. I'm going to paste that in here. Make sure that's big enough for you to see. Okay, so CH4 plus, and the plus just means and, like there's more than one kind of molecule. So you have this kind of molecule and we have this kind of molecule. So let's go ahead and let's draw those. And I'm going to kind of color code each of my types of atoms that I'm doing. You don't have to color code when you do this at home. In fact, you know what? I'm not going to color code because I'm going to do it how you would probably do it at home. Okay, so the first thing we're going to draw is this molecule right here. And this molecule has a C in it. Okay, so I'm going to draw a C. Okay, that's my carbon atom. And then it's got, and there's no number after that, which means there's just one C. Okay, and then it's also got 4 of these H atoms. So there's H4. That means there's 4 H atoms in that molecule. So I'm going to draw those and attach them. And it's a little, my drawings aren't very good because it's a little tricky with the mouse. That's okay. As long as I can tell what atoms I have and which ones are connected together into molecules, that's what I want to see. Okay, there we go. That is my CH4 molecule. And there's only one of them because there's not a number here in front. Okay, so in my reactants, I have a CH4 molecule. That's that natural gas, that methane. Okay, and the plus sign means and I have 2 O2 molecules. Okay, first thing I want to notice is there's this big 2 in front. That means there's going to be 2 separate molecules. Just to remind me, I'm going to put like 2 dots down here to say, okay, I need a molecule here and I need another molecule here. I should have 2 molecules. Okay, and those molecules are each going to have oxygen atoms, and they're each going to have 2 oxygen atoms. So I'm going to draw an oxygen atom. And down here, I'm going to draw another oxygen atom, and I'm going to connect them together. And then I need 2 of those. So I'm going to do the same thing over here. I'm going to draw an oxygen atom. And I'm going to draw another oxygen atom. And I'm going to connect them together, okay? So these are my reactants. I have this molecule, CH4, and I have 2 of this molecule, O2, okay? And now what I'm going to do, if you're using Sketchpad, is I'm going to hit export, that little save button, and I'm going to say save PNG. I don't know why, I just prefer PNG files. And then I'm going to add this into my box. Now, if you're doing this on paper, like most of you probably are, you would just take a picture of your paper. Okay. Here's what I'm going to do next. I'm going to come over and here are my products. I'm going to draw my products and I'm going to put that picture over here. If I was doing this with Legos, I take my Legos apart now and rebuild those. But since we're doing it on drawing, we're just going to draw those. Okay, and I'm going to start over here. And so I'm going to go a little quicker since we already went through it once, but I'll talk as I go. Okay, so we're going to make this molecule now, CO2. That's carbon dioxide. That's like what comes out of your, that's what you breathe out. It's what's in soda pop, that fizz. And it's also what is in, when you burn anything, whether that's like you're burning wood or you're burning gasoline in your car, okay, you're burning, you're making this carbon dioxide gas. This is kind of, I'm gonna make this a funny, it's like an elephant ear molecule. Okay, so that's my CO2 molecule, a carbon atom and 2 oxygen atoms. And I'm gonna make 2 H2O molecules. So each of those is gonna have 2 H's, because that's H2 means 2 H's. And I call this the Mickey Mouse molecule. And you don't have to remember the shape, but it does just kind of have this funny shape, okay? All right, that's an H2O molecule, and I need to make 2 of them, so I'm going to make another one. All right, so I have my CO2 molecule, and I have 2 H2O molecules. And these are my products. These are my molecules after my chemical reaction happens, okay? And I'm going to save these or export. And I'm going to put that into this box here. Oh, I don't like that. I don't like that one bit. Let's get those together. There we go. Okay, so these are my reactants. These are the molecules before the reaction. And then what happened is these atoms, okay, kind of broke apart from each other. They kind of shuffled, rearranged, and now we put them together in a new way over here, okay? So remember, a chemical reaction is when atoms, okay, the atoms that are in a molecule kind of split apart from each other, they rearrange, and then they reconnect in a new way. And that's what happened here. Now using this, using this, let's go down and let's do our conclusion. Okay, and we're going to kind of be jumping back and forth a little. In fact, I'm going to zoom out and maybe we can see both. I'm going to delete this box. I don't want you to delete it on yours, but I'm going to delete it so that we can see these kind of together a little more easily. Okay, here we go. All right, so for the conclusion, we're going to fill these in with either always, sometimes, or never. And for this, you'll have to go up and look at, you'll want to look at more than one example to kind of compare whether it's always, sometimes, or never. But I'm going to walk through it just with this example. The type of atoms. Okay, here's what I want you to notice. Over here, we had carbon, hydrogen, and oxygen. We had C's, we had H's, and O's. Now, those atoms reshuffled, and over here, they made new molecules, but they're still, each atom, if we look, is still C's, H's, and O's. Okay, so the type of atoms that we had over here, C, H, and O, are the exact same atoms, type of atoms we have over here, C, H, and O. And if you go through the rest of the examples, you'll see that's true. Like over here, we have zinc, we have hydrogen, and we have chlorine. And if you come over and look in the products, we have zinc, chlorine, and hydrogen. So the elements always, I'm going to put it in caps, always stays the same. Okay, let's go look at the number of atoms. Over here, let's count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 atoms. So we have 9 atoms in the reactants. After the reaction, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9 atoms in the products. The total number of atoms always stays the same. Okay, let's just talk about this for a second. The reason that the type of atoms and the number of atoms always stays the same is because we're just taking those same atoms and we're reshuffling them to what's over here. Okay, so it's the same atoms, we're just combining them in different ways. So it makes sense that the type of atom and the number of atom would stay the same. Okay, the type of molecules always, sometimes, or never stays the same. I want us to go back up, and I'm going to type it here, but you should have already typed it, to the definition of a chemical reaction. We said a chemical reaction is when molecules change into different molecules. That's the definition of a chemical reaction, is the molecules change into different molecules. Like here, we started with these two kinds of molecules, but when those rearranged, we had new kinds of molecules. The types of molecules, never stays the same. Okay, because that's what a chemical reaction is. The type of molecules is changing, so it never stays the same, or else it wouldn't be a chemical reaction. Okay, the total number of molecules sometimes stays the same and sometimes not. Okay, so sometimes we could have, like up here, we took 2 small molecules and we combined them together into a bigger molecule. So the number of molecules changed. Here we took a big molecule and we broke it down into smaller molecules. So the number of molecules changed. But sometimes we're switching around the atoms, but we'll still end up with the same number of molecules. Like here we started with 3 molecules. We kind of changed them into different molecules, but over here we still have 3 molecules. So that's a sometimes thing. That one is probably the least important one. These are the important ones, okay? The molecules are changing, but the atoms are always staying the same. Okay. Using the words atoms and molecules, what happens? Let's just say what we just said. The molecules are changing. The atoms are staying, and I'm going to put this in all caps, the same. They are just moving around and reconnecting, let's say. Or you could say rearranging. I'll let you choose what word you like best, okay? So each of those atoms is the same atom. They're just moving around and reconnecting. I like to think of it as like a dance. You go to the dance, and maybe you show up with one date, you show up with your date, but during the dance, maybe you hang out with your friends, and then during a certain dance, you move and you like have different dance partners, okay? So even though you're moving around and you're joining different groups, like all the people in the dance are still the same people. They're just kind of, making different groups, different connections. All right. Look up a definition for the law of conservation of matter. Okay, the law of conservation of matter says matter cannot be created or destroyed during a chemical reaction. Okay, so matter, like in the Avengers, if you've ever heard of those guys, and I have not seen this movie, so this might be wrong. I think like a dude snaps his fingers and like part of the universe disappears. That can't happen in real life, okay? Because in real life, we say matter cannot be created or destroyed. Like you can't just make matter disappear or appear out of nothing, okay? That we call the law of conservation of matter, okay? And why can't matter be created or destroyed? Okay, it's because atoms can't be created or destroyed, at least not during a chemical reaction. So we're going to say atoms cannot be created or destroyed. Okay. Actually, I'm going to back up a step. I'm going to say during a reaction, the atoms move around and reconnect, but they stay the same. Since matter is made of atoms, matter can't be created or destroyed. Okay, so basically what I mean by that is if all the atoms over here during a reaction are the exact same as all the atoms over here, okay, we didn't destroy any atoms, we didn't create any new atoms, those atoms stayed the same even if they were kind of reconnecting in a different way. So because of that, we'll say, well, matter can't be destroyed because matter is made of atoms. And if those atoms are staying the same, that means the matter is still there, okay? All right, that is the video. I know it's kind of long, but hopefully it helped go through how to do these examples and then how to answer your conclusion. All of this conclusion stuff is going to be really important for understanding the rest of this year. So I hope that helped. Thanks.